Okay, question 3 of the short response questions. A function is defined as f of x equals x times ln of x squared for x is greater than 0. The graph of the function is shown and has a local maximum point at A and a global minimum at point B. The derivative of the function is given by f dash of x equals 2 ln x plus ln x squared for x is greater than 0. Verify that there is a stationary point at x equals 1. Okay, well, at stationary points, f dash of x equals 0. So we've got 2 ln x plus ln x squared. So we're checking, does this equal 0 for x equals 1? So we can factorize this as ln x is common, and we're left with 2 plus ln x. So this means either ln x equals 0, which means x equals 1. Remember, ln of x equals 0 can be rewritten as e to the 0 equals x, and anything to the power of 0 is 1, so x is 1. So we verified it. So f dash of x equals 0 for x equals 1, therefore it's a stationary point. I think you can get away without writing the sentence, but I always like to answer the question. Determine the coordinates of A. So A is our local maximum. So if you write the factorized form of our derivative from part A, we know that f dash of x is ln x times 2 plus ln x. This led to x equaling 1. So this will equal 0 as well, which will give us the value of A. So 2 plus ln x equals 0. So ln x equals -2. Remember, this means e to the power of -2 equals x. So for A, we know the x coordinate is e to the -2. And now we have to find the y coordinate. And we're given the equation for y. It's x ln x squared. So y equals x ln x squared. And we want to sub in e to the -2. So this is going to be e to the -2 ln e to the -2 squared. Ln and e cancel each other, so that's just -2 squared. That's e to the -2 times 4. So 4e to the -2. So our coordinate for A is e to the -2 and 4e to the -2. The graph of the function has a point of inflection at x equals e to the power of p. Determine p. So remember, point of inflection means that the second derivative of x at that point will equal 0. So if we derive our first derivative, that's going to be derivative of ln x times 2 plus ln x. As we've got two things multiplied by each other, we can use the product rule, such as y dash equals u dash v plus uv dash. And our u can be ln x. So our u dash will be 1 on x, and our v will be 2 plus ln x, and our v dash will be 1 on x. So we can derive that here. That's going to be 1 on x times v plus u, which is ln x, times v dash, which is 1 on x. This is going to be 1 on x is common, 2 plus 2 ln x, which is, so 2 is common as well, so 2 over x, 1 plus ln x. And we want this to equal 0 at the point of inflection. So now if I times both sides by x, we get 0 equals 2, 1 plus ln x. Divide both sides by 2, so we have 0 equals 1 plus ln x, minus 1 on both sides, minus 1 equals ln x. Do e to the power of, so e to the power of negative 1 equals e ln x, which is e to the power of negative 1 equals e and ln cancel each other, which is x. So p is going to be negative 1.